Ladies and gents, welcome back to another Engineers podcast. Today I'm joined by Ryan Stevens, the legend from the legendary Ramp, who are a major player in New York, all-in-one spend management platform. And he's the director of applied science. We've got a great breakdown in the show today in regards to what it's like to be the first ML hire in their risk and growth team at Ramp, building 0 to 1 ML infrastructure and platform products, and to where he feels the future of LLM infrastructure and deployments going. So we've got a really current conversation with someone who has been there, who's done it, and I'm looking forward to getting into today. Ryan, thanks for coming to join us.
Yeah, happy to be here. Excited about the conversation today.
So am I. Will we start like this? Kick us off with a bit of background into Ryan and set the scene for who we're speaking to, if you like. And then the elevator pitch into Ramp and talk to us about who Ramp are.
Yeah, sounds great. So Ryan Stevens, Director of Applied Science at Ramp currently. So I lead teams across risk and growth. We do ML, we do LLMs, we also do analytics warehousing. We do sort of the full stack of data work. Kind of started my journey as an econ PhD student. I studied industrial organization at NYU in New York, so like big New Yorker here. I focused on point of sale data for supermarkets across the US. That's what my thesis or dissertation was on. And so that was like my first foray into big data. This is like terabytes of data, 50% of retail stores across the US, as well as some ML. So I had a little bit of ML knowledge there. I got to work with our high performance clusters. That was the day where Hadoop was still like all the rage and the thing that everyone wanted to do. Times have definitely changed. After that, my first stop was Meta. I was supporting kind of ads ranking. So that's the teams that are building the big deep ML models at the very end of the ad stack. So those ones that get a lot of the hype, I would say. I would say that was like a really good journey into seeing how ML infra was built, what the workflows were, and you could just like kind of soak up all of the really interesting and useful articles that people had written internally over the years about like the decisions, the choices, the trade-offs that they had made to sort of make the stack what it was. After that, I joined Ramp, kind of first ML person embedded in risk, built the first ML models there. We'll talk about those and what that journey was, and now leading a team across risk and growth in a few other areas. And so, yeah, it's been like a great journey. Just the elevator pitch on Ramp. So yeah, Ramp, we like to save businesses time and money. We started as a kind of a corporate card expense management that was our dual product offering. And then we've grown. We're now multi-product. We have treasury account. We have the ability for a business to invoice, so pay their vendors. We also allow you to manage your vendors on us. We have integrations with HRIS systems, accounting systems, banking systems. So we're kind of like, you could think the nervous system of back office finance. And our goal is really to make sure that you have visibility, no spend is wasted. You're able to really run your finance teams efficiently and focus on like the more higher value strategic tasks that you would rather be doing. So, yeah.
Ramp is, I said legendary. It's one of those names that I see people reference to. They do put them on I mean this in a positive light, a pedestal in terms of what they've built, the growth journey that they've been on, the engineering bar. So it's an honor to have you guys on talking about some of the stuff that you're doing. I think a great place to start would be first ML hire in the risk team, and talk to us about foundationally some of those conversations, really early days, you coming into the business, and the ideas in which you wanted to go and build something. What did that look like?
Yeah, that's a great question. I think to like set the stage, risk is like a natural place for ML. So, unlike maybe some other areas, there was already a natural appetite and experience for what ML could bring. So, we didn't necessarily have to have value conversations. Sort of later in the journey at Ramp, you do have to have those value conversations because it's going to be like new kind of fertile ground where maybe these types of approaches hadn't been used before. So, yeah, early days of risk looks very similar across many companies. You have really experienced subject matter experts who build basically rule-based systems. That's sort of what the stack looks like. So really smart people. We had very little data, so you just have to like use your intuition, your expertise to kind of build these rules. I come in, that's sort of where it exists. Now, the key conversations I actually had early on, I had no risk experience. I did have a econ PhD, so I sort of like had some knowledge in the milieu. But you know, the first conversations you have is just like, what are you doing? What are you optimizing for? Like, what is important for you? Just like kind of soaking it in. But from the ML standpoint, it's really always like a recipe. So one of the things that like I had a really good PhD advisor, and he was like, just turn everything into a recipe. If you turn all of your papers into a recipe, everything becomes easier. It's always like what you want to do. So ML has a recipe, and that recipe is really just this. You need to first know what the label is. You first need to know what you're optimizing for. That's what we say in economics. Like, what are you optimizing for? And so for that, it's like, what is the label? What is the thing that you're going to judge the performance of whatever your system you're building against? And actually, in risk, it's like a very difficult conversation. It's very theoretical in a lot of cases. So just to also give you a sense of risk, risk has credit risk. Credit risk is we are functionally lending a customer money for 30 days, very short-term loans, short duration. And then there's fraud risk. I started on credit risk. It's actually a question mark about what kind of delinquencies do we care about? What is a delinquency to us? So a delinquency is like a customer not paying us back. And so there's a lot of conversations about like, what if they don't pay us back for 30 days, 60 days, 90 days, 120 days? How does that label work? How do they all look sort of over time? So really like you come into a problem, you're talking about labels, you're talking about what they're optimizing for, you're getting alignment around that. You want everyone to have a North Star. Once that's done, then I would say like the ML comes in. And the ML is the question of what data do you have? Have you logged the right data? Does it actually exist? There's usually a lot of hype in a lot of areas about, oh, we could bring ML or even, LLMs to this area. But if you've not logged the right thing and you've not logged it throughout history, you have no chance. So then you have those logging conversations. Like what data do y'all have? Is it clean enough? Is the quality there? Is like who understands it? And so it's a lot of conversations then with like your backend engineers who usually built the applications that are logging that data. And then it's just doing stuff in notebooks and then figuring out how do I get this thing that I had in a notebook to actually run continuously somewhere else. And really sort of at Ramp, it's no different than anywhere else where ML is done. Like ML is done at first in notebooks. Sometimes it never leaves the notebook. And then the question of like, how do I take this thing that I did in like a local environment on my computer, and then get it to run, I'll use like a general term, in production. And yeah, early days, it's very hacky. I think we orchestrated it by having like a scheduled notebook run in a production environment, and then that dumped the data. Luckily, we had like a good database team by that point. So it was in a database. It wasn't just like a CSV file sitting in S3 or something like that. Like that is a very natural part of the journey. But yeah, that's how the first sort of ML models get built. It's like label conversations, get your features, do something locally, hack your way to production. And then you have something that is delivering value. And then from there, it just gets harder and more fun.
Love it. I do want to talk about the harder and more fun stuff. And also, for what you can share. Where have been some failures or some learnings? I think they're really important messages for people in the community to try and pick up on. We've moved from this first hire of scrappy, hacky, labeling, notebooks. Talk to us about where you are today, that journey, and some of those failures.
Yeah, that's a good question. So yeah, where we are today, yeah. So we had this like hacky notebook, train it there, get the data out there somehow. And now we have like, I would say like a few kind of core pieces. And actually, I think the core pieces will allow me to talk about the failures quite well. So one of the early things you realize when building ML platforms is that if you let everyone do ML their own way, the real cost to ML is actually like maintenance more than it is like initial development. Now, it is true for like extremely large training jobs that they can cost a lot. Most companies are not. That is not the thing that actually will cost the most. What will cost the most is you have a model doing something. No one is sure how that came into existence. No one is sure like what the monitors on that look like. So that was like kind of the first piece of core infrastructure we built, which was like a YAML based training and deployment system. This is like this was some learnings from Meta. They have like config driven development and deployment. And a lot of places have this, but that was like kind of the first big thing is like, we want to have a unified single language through which everyone trains their models, brings in data, and deploys it. That helps to like narrow the scope of maintenance. You can see this model came from this config, from this simple file. It also, I think the other thing you realize too is like ML hiring is very hard. It's very difficult. It's like a mix of quantitative and business insights in a way that you're trying to find the right person. So it's actually better if you can find just smart people and you can train them to do a little bit of ML. And having a config system that is very opinionated is actually just like a learning system. So they can just go and look at these very short config files and be like, oh, okay, this is how the structure of these models are. This is features. This is how everything works. And so like actually as a learning device, it's become extremely useful. And you also realize that tree-based models have become amazing. They solve 90% of tabular problems out of the box, especially when you're 0 to 1ing. So the other thing about the configs that you realize is like they're mostly the same. And so, yeah, that was like the first thing is how do we just like make the workflow of training and deployment as simple as possible? I would say that was actually successful. There wasn't like a ton of mistakes along the way there. We did some refactors as one always does. But I would say the more difficult thing and where we've invested a lot of time and we'll have some interesting stuff to share like more broadly soon is on feature development. So in risk, in fraud, let me talk about this application because this is where things get really fun and exciting and difficult really quickly. So transaction fraud, we have cards. You can just think of them like your debit card, like a credit card. So you swipe at a merchant, just like any card you have in your wallet today. And when you swipe it, we have to decide whether we think it's a fraudulent transaction or it's not. That decision needs to happen in 300 milliseconds, or give or take, something like that. So that decision needs to happen very quickly. So you want an ML model there. Awesome. That's super great. Everyone does. Everything needs to happen very fast. Now, that is your online thing. That online thing needs to happen very fast. You want to train this thing offline. You want the same data that you're using for your online transactions to replicate offline. This online offline parity issue is extremely difficult. There are a lot of conceptual challenges to it. So let me just give you like an example of one. Let's say you discover a bug in your code. You were not, let's say, logging the merchant for some reason that this transaction was happening at. And you then go and backfill that data. So you say, we have a bunch of like missing data. I'm going to just like go back in history and fill in those values. The question is now when you go train a model using offline data, should you use those values that you've backfilled or should you not? At the time of decision, you didn't have those values, but now you do have those values. In that case, you probably should use those values if this thing is fixed going forward. But you could think of a different scenario where, let's say all of a sudden your payment processor, they didn't have merchants. Now they tell you the merchants today. So you actually can't go back in time and fill in that value. And so the question is should you use that value in training, even though it's going to be null, for it's not going to exist like in the past. So there's a lot of subtle issues with regards to past data and present data, just conceptually. So that's like the first difficult thing. The second difficult thing, and this is where like infra and all of those things come into play, is trying to have an ergonomic interface UI so that people can write features. So like, what merchant was this transaction at, for example? That's a feature. It's just like, what merchant was this at? Or was this merchant a gas station? That could be one of your features. Having an ergonomic UI where someone can do that backfill. So I want to backfill it over all the past data. I want to train a model using that historical data. And then I want that same feature. I'm like, that's great. Now I want that 300 millisecond decision to use that exact feature. Those are actually different problems. One is like a batch job of thousands and thousands of transactions, and it could take days to run. That's fine. The worst thing you're doing is you're paying like kind of time to wait to train a model. That could take days, it could take weeks, but that 300 millisecond decision needs to happen in 300 milliseconds. So having a single UI, we call it like a universal interface. Some could say an API even, where a developer can write a feature, do this long historical backfill, and then we also deploy the same code into production. It's been a journey, to say the least. And the reason we've like this has been the North Star, this has been the vision, is what happens to most organizations is there's a split in roles and functionalities. There is the data scientist, MLE, that will write a feature for these offline backfill training jobs. And then there's a production engineer, maybe an MLE, maybe an MLOps, separate person that translates that into the production code. That translation is very costly. It is extraordinarily costly. And I think a lot of organizations don't sort of understand how costly that translation is. They have to be in sync about what the feature means. They have to be in sync about what monitoring means. Basically, they have to be the same person, is what you realize more and more over time. And so developing our feature platform, which is now all internally built, has been that journey to how do we get this universal interface that allows us to have one definition for a backfilled thing, and then also we can deploy it and it can run in under 300 milliseconds. Luckily, like tech has really developed, especially on the database side. And so we're using like sort of cutting edge streaming database technology for this. And there's like some new APIs that kind of allow you to mix and match the backends you want to use. So you can sort of run this code on your analytics database. You can run this code on your streaming database, same code, same front end. And so like we are lucky in the time that we're in that we can leverage technologies that already exist. So yeah, I mean, most difficult problem by far. And I think that you talk to any ML person anywhere, they will say that's harder than anything else. Yeah.
How long did the feature development platform actually take to build?
It's a good question. It's all like been an iterative process, and we swap tools. So overall, like it's been about a 2-year-ish journey for when this vision was set. We have made incremental progress in it, but like I think any organization that like wants to take this journey needs to kind of time box and realize it's going to take like a long amount of time. And the other thing is like growth is a gift, growth is a curse. It is a gift because it allows us to do like these amazing things. It allows us to bring value to a lot of people. It's a curse because we grow so fast that we get to have that fun problem of like, like scale like we are hitting scale blockers much faster than most companies do. So like other companies can kind of develop this technology with like assuming a growth rate of data that's like kind of small. They're like, we're going to grow a little bit like this. But when you're on the exponential slope, you develop a technology today and you're like 6 months from now, you're like, oh, wow, like that's not the right choice. And so that's also been like an interesting challenge for us, is that our scale is so big that your like technology choices have to sort of change, or this is today, don't reflect tomorrow. Yeah.
Yeah, that's quite an interesting problem actually to try and unpick, because you're building something that solves today's problem, but when you are on that journey that I know Ramp have been on, it's difficult to predict where you will be in that 12-month period and what technologies you need to leverage.
Yeah, that's exactly right. I mean, luckily, like we have extremely good engineers and we have a really good community, like of people around us that we talk to. So we talk to the new companies, we talk to the people at the bleeding edge. And so we do, like, part of the reason it's been a little slow is because we do have that vision of like what we need, and sort of we have the high standards. And that's sort of what you kind of have to do here, is like you have to really hold a high bar. And you'll make trade-offs. You always make trade-offs. You make like hacks, and you will like down scope, to use that term, along the way, just to make sure you're actually delivering value for the business. But making sure you hold a high bar, making sure you like set that vision, like this universal interface is what I want. I will not, I will like sort of fight tooth and nail to like keep that as the vision and make sure you keep that consistent. That kind of allows you to say, okay, yes, we're making a technological decision today. We might be making some like architectural decisions that will like allow us to have value, and we know they're hacks, but as long as we're on this shared journey, it sort of does allow you to at least be like, okay, scale will happen along the way, but we all sort of know where we're going, so we can kind of like rotate and make sure we don't build anything that's like gonna box us in going forward. Yeah,
Exactly. And even if we just wind back to the training and deployment platform, that probably really set a foundation for you internally to do ML Ramp's way. You talk about it being this unified set of standards, rules, or consistency was the word that I had in my mind of, this is how we do things. This is our nucleus, our go-to. That probably set the tone for this universal interface.
yeah, that's exactly right. Yeah, the fact that we had a successful universal system that many people used, and people could see the benefits of that. Like we were able to scale from basically like 2 or 3 people doing ML to, I think, like last count, like 12 people deploying models, and a few of those that's like the first time. And having that success standard, one, it like buys you trust because it kind of like shows like, okay, like this is the workflow, we know what we're doing here. But also it like buys you sort of an understanding of architectural decisions here are pretty important. And also, I think maybe you were alluding to this. It's like that became the solved problem. Like on your journey of ML, you'll hit the blockers, and once you hit the blockers, that then says, okay, it's time to build that. So like we were able to train so many models and deploy so many models that we started to like see this problem cropping up more and more and more. And because you see this problem cropping up more and more and more, and that's like offline online consistency, being able to have that trained deployment be the same thing as you run inference. Like once you hit a problem enough times, you just say, okay, this is the time to build. And like I think that's true for like organizational change. It's like you want to be as proactive as possible, but you are trying to make sure you're like focusing on delivering value for customers and for the business. And so you will, tech debt is not a bad thing. It is like you take on debt because it's an investment. Your credit card debt today is because that cash that you have in your bank account is worth more than like paying it down to, I don't know, pay for your dinner tonight. You do want to like, you can make a smarter investment with like the actual hard-earned cash in your bank account. And so like you accrue debt until that debt starts to become costly. And it becomes costly because like you start to have multiple times within like your journey where you see the same problem cropping up. And at that point, you're like, okay, this is actually problematic. And now like we want to pay it down. and put ourselves on a firmer footing. And so like building that universal interface for training deployment means like you actually start to get more universal support for like this is a problem because like 5 people have experienced, as opposed to like, you know, one person or myself being like, in theory this is going to be a problem. You can and say no, actually 5 people have seen it, so they all know.
What would you say would be, over your few years at Ramp, what were the 3 things that maybe you would do differently if you had your time again?
Yeah, that's a fantastic question, and it's funny because it's a question I ask in like every interview, is if you self-reflect on your journey or on your projects. Yeah, I think the first thing I would probably do differently, is I would I would do more educational courses on the importance of monitoring, um, like data-driven applications. And what I mean by that is like, so I come from economics. A big thing in economics is it's called the credibility revolution, but really it's this concept of, I'm not going to go too deep here, but it's really like, you're trying to make a claim with data. So you're maybe trying to say something along the lines of uh, um, like unemployment benefits lead to like higher consumption. Like giving people unemployment benefits like causes them to consume more, or is like good, like leads to like high economic growth or something. An economist would come and say, in theory, that sounds good. Um, or there's some theories that say yes, some theories that say no. I would like to see an experiment. I would like to see some data. I would like to see an explanation for like why that causal chain exists. And basically all the economist is really asking for is, I'm looking for something very precise to measure here. And being able to measure that thing precisely allows me to have confidence in whatever thing you're doing here. And why I talk about monitoring is, I think of monitoring in 2 ways. I think it's performance, like, is this thing performing like we expect it to? And then data correctness. So, like, is the data going into it what we expect it to do? And what you sort of realize is like that fealty to the problem and to the data is like not a shared concept. It's something that like comes with experience. Economists are not physicists. Our data is garbage oftentimes. It is generated by the real world, and the real world is messy. And so you sort of learn, I think, that problem very, very quickly as an economist, that other like natural sciences or other more quantitative disciplines that don't. So like more deterministic disciplines. And so, yeah, monitoring. I think like if I could just go back and be like, I should have just like made documents, I should have like made speeches, I should have shown examples about like actually once you have like data intensive applications that are making automated decisions, like monitoring is more important than anything else. I think that's one. Yeah, I think 2. I don't know if I'll have 3, but I think a second, yeah, a second big one too is like, I was not as I did not fully understand the value of LLMs early. Um, I think I understand them a lot more now from like a personal perspective, but I certainly was like an old man in the room, uh, 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 where you see a hype technology, you're like, no, ML is done one way. This is how you do it. It can never do that thing. Now there is like still a place for ML, especially in financial and fintech companies, because like your fraud risk models need to run it under 300 milliseconds. They need to be very stable, all of that sort of stuff. So there's still like a big room for like traditional ML. But I definitely was not like hyped to LLMs like early enough, or really understands like where the applications were, where like the value was being driven. So yeah, I think that was like a really big like miss on my part. Definitely self-corrected, but yeah.
Well, exactly. That's a really nice segue into. Should we talk about LLMs, AI? Where are you using it at Ramp? And almost just download on me what you guys and girls are doing with it now.
Yeah, that's a great question. I mean, everywhere, I would say
Yeah, exactly.
is
Yeah.
where we're using it. Yeah, so let me talk through like kind of three different areas or three different like maybe framings of where LLM is. So like one area we use it a lot for is like taking unstructured data and structuring it in some ways. Um, so like a good example is, and we've written about this online, is like uh, if you are on Ramp, you one of the most frustrating things, I think everyone has had this experience. You have to expense something. So you've made a purchase somewhere and you have to expense something. And you log into whatever UI is. Some are clunkier than others. I will not name names, but some are clunkier than others. And there's like a box that is like, give me the accounting category of this transaction. And you're like, I'm not an accountant. Like, why do I have to tell you what accounting category? And usually what you do is you're like, it's like probably like benefits or wellness or something. And you're just like scrolling and you're like, okay. And so one of like our first applications for like, it's a mix of LLM, it's a mix of RAG, but it's to like, okay, how can we just like do that for you? Because most of the time it's like an employee spending, it's probably like a wellness benefit or something like that. Now there is like a full system here, but like where LLMs are like very, very good is like twofold. It's like the metadata that comes with that transaction is going to be the same and different. So you get some information maybe from the merchants. Some merchants give you certain information, some merchants don't give you the same information. You can actually just like shove those into an LLM and be like, maybe complete some stuff. Maybe actually like, we're actually looking for these fields. Can you just like put these fields in a JSON and then go? So it's actually, a human can do that very well, but a machine can do that sort of at scale great. So you have like different information that's all sort of related, and you're like, I'm just looking for the merchant name. And it's just like, just give me the merchant name. It's like, great, it can do that. Also, these LLMs, or at least like the APIs for them, you can get like very large universal embedding. So you can get vectors of numbers that represent those things, and then you can do RAG very quickly. So like, just like the first theme in the first place, like, and we use this in many different places, is like, you just want to get some structure out of like unstructured data. LLMs crush that. Now, I do want to say that it still is a traditional data problem, in the sense of, you're still like, if we go back to like the very beginning, when I was talking about defining labels, defining what you're optimizing for risk, like we still focus on a narrow goal. And our narrow goal was, we want to make sure that when an expense comes in, you do not have to select the accounting category, and we select a high quality accounting category. So it's still like a traditional ML looking system. And that was still like the vision of where we were going. And that's how we knew this was successful. But like, what an LLM did is it basically allowed you to like engineer a good feature, and then engineer a good sort of set of embeddings, and then sort of make this process like work well. And I think that's also like, if we're going to talk about just briefly for a moment on failure modes, it's like defining your problem and what you're trying to solve. Like, LLMs will not define your problem for you. And so like having that clear problem to solve is like extremely, extremely important. So that's like one big area. I'll pause for a moment if you wanted to.
No. I like that. Like, define your problem first. Don't throw LLMs at solving anything in your business. It's all context dependent. Everyone, I imagine, wants to use it in some way, shape, or form right now. It's the hype. People want to be AI native, but solve the right problems with it first.
Yeah, that's exactly right. Yeah. Okay. So like unstructured to structured data, that's like thing one. I think like very, very important. I think thing two are like another sort of really big area for us is how do I actual like almost AI. So that, I would say that you could call that like feature engineering. If I just take it back to ML, what I just talked about was like feature engineering. Now you could actually say like, it is your model. We'll go to like, it is a product in a moment, but like, I think that's the second area, is like, it is your model. So what do I mean by like, it is your model? It's like, it is actually going to like make a decision for you, or it is going to like give a prediction, let's call it, like itself kind of fully closed. And so like, one area that we've talked about this, which has been very successful, is like, one of the most difficult things when customers are switching to Ramp, or any business, is like, if they're using our card product, they're probably already using cards. And what we want to do is we want to make that experience of moving card spend from like a current provider to Ramp as like frictionless as possible. Like those migration and transaction costs, as they're called, are the highest friction thing. Also, we are a low priority for a business. They're trying to make money. They're trying to survive. It is tough. This should not be the thing that they're thinking the most about, is like, how do I get set up on like the newest vendor that I have? And so the like historical process for it, and a lot of places have this, is like, you give us a PDF or you give us a sheet of all my historical transactions, and then maybe a human inputs it, or maybe we have like a really like deterministic code that tries to parse it. Super error prone. The fun thing about the US is we have more banks than anywhere in the world, just like per capita. I think that's true, but it certainly is true that our landscape is very fragmented. We don't have like universal APIs. And so many banks do things their own ways. So there's no universality to this. So this actually migration experience in US banking is like extremely difficult because of the diversity of the things that like happen. Having said that, a like smart person can go and look at any set of statements and tell you, okay, that's this column, that's this column. Okay, I need to exclude. So like this is, I think, one of those like well-scoped, well-defined problems that you're like, someone with little context can go do very well. So yeah, that's what we have. This used to be like traditional, a little bit of OCR, a little bit of just like coding, doing like matching, all of that sort of stuff. And now it's basically AI, which you can have it do a multi-shot sort of exercise of iterating through these. To you give it, you'll be like, okay, try to find this data for me. Okay, do your best, do some validation. Okay, try it again, try it again, try it again. It's one of those like iterative problems. It's also like a good, I would say, like place where it will be a step change from the prior experience. It will still get it wrong because these things can still be a little like different for different customers. But it's like a thing that intuitively sort of a person can do, and so you think like a machine can do it really well. So that's like a full agent, kind of no human in the loop, nothing, like full like enclosed experience that we have, and it's been like extremely valuable. And it also shows like a new paradigm, because historically, I even in my time, this was just a data cleaning exercise, and I did millions of these, and I think they can clean data for you quite nicely.
Yeah, and because you're a self-confessed dad in the room of LLMs, we spoke about this offline, and this I know is an important topic for you, that you're trying to absorb as much as possible from other people, or interested in what other people's thoughts are. LLM infrastructure and cost, etc., etc. Where are we going with that in the next 3 to 6 months? We deliberately wanted to put that timeline on it because anything beyond that is who knows. So where do you think it's going, and what's your advice for people?
Yeah, it's a good question. So, like the per token cost will continue to go down. It will continue to go down for the foreseeable future. There is still money flowing in, so there's still a lot of investment in the space. There are still major players. Just from like my economist, perspective, there's still a lot of competition on the foundational model space. So like the thing about like any business decision, so like it's not just LLMs, but if you're thinking of a business, you should think about where your cost structure is going to be in a year, 2 years, 3 years, 4 years, 5 years. That is like, just like take Amazon or something as an example. Like I guarantee you the first books that they shipped, the first books that they sold were very expensive at a per unit cost. But the vision was, with economies of scale, both from like a technology perspective, but also from a delivery perspective, they know that unit cost will drive down. So they built with the forecasted cost curve. So I would recommend everyone just go look at the token prices. We've also published some stuff on the token prices. We have some interesting data that we've shown ourselves, but they're just going down. So you should not think about what is my cost structure today. You should think about, look at those curves, assume they will go down, and they will,
Yeah.
because that is like how these prices will work. And that is how you should build. Now, there is other costs associated with LLM infrastructure. It's not just like, are my APIs, can I hit basically an API, or can I self-host a model? There is like self-hosting costs, and I think it's up to the business and up to like the engineering and where they are. Do you self-host, or do you like only do API integrations with like third parties? But I think there's also, I would say, everything else that we've just talked about is also like an important thing, which is like the data. You'll still have to have local data. You'll still have to have the context for it. You'll still have to think about how we're storing everything internally. You'll still have to have interfaces for people to work through. So actually, like the LLM infra space, what's interesting here is like UI and workflow is king. And figuring out like the right third parties, the right vendors, for UI to make like that experience great is actually where like a lot of, I think, the difficulty with running a business is today. Because I think on the pure like hosting side, like how do I get GPUs, like more and more of the cloud service providers are like providing that if you do want to do anything like self-hosted locally. And that is like a space that will continue to develop pretty rapidly. So you can kind of assume that it'll get like commoditized is the general term. It'll get easier and easier and easier for you to like self-host a llama or self-host a different type of model. It's still a little difficult today. There's still like technical challenges, but similar with like cloud development before, it was very hard. You had to like have your own servers. You had to have people that would like know how to hook them up for on-prem and all of that stuff. And now it's just like click of a button. Assume that hosting problem is going to get solved because they have a lot of experience solving it. Now, what's not, solved or what's getting more difficult, and this is where the theme that comes through sort of how I think about problems is like workflows, deployments, getting that hooked in your application, all of the exhaust of it, all of the inputs of it, like that whole thing. There's a lot of interesting vendors out there, and that's like an unsolved space. And really that's like a UI UX problem. How do we like conceptualize the workflow for getting LLM applications into production? How do I make that easier? And then how do I make the monitoring, triaging, deploying, all of those things that like more and more simple over time? So I think the space is like, that's where a lot of the development is going to happen.
That's super interesting. I know there's a lot of people, companies right now, and some conversations that we're in the process of having, especially on tooling, authentication, all of these things that actually link up the ecosystem, I think are in the works, and they need to solve that problem next 3 to 6 months. You touch on a really interesting part that I'd never really looked at, but the UI UX part. That's going to be the interesting problem to solve. That's probably the overarching umbrella, actually, of some of the things that I've just mentioned myself. But I think that is the really interesting thing to look at in these next 6 months.
Yeah. So like you can think that no code, low code is really where LLMs and a lot of these agent frameworks need to go. Now the space has some of these from a backend perspective, and there are players that are like developing these sorts of things as well. But like, how do you bring LLMs to your less technical sort of parts of the company? How do you not need, like a full ML engineer to do it, or a full, LLM engineer to do all of these things? And I think that's the real question and the real interesting problem. And how do you deploy them safely, both from like a security standpoint, so like making sure that they like don't consume data that they shouldn't consume, or they don't output things that they shouldn't output, or that data doesn't go somewhere that you don't want it to go to. Those are like also like interesting like backend problems. But I think like these things are so good at what they can do, and you should assume that like the prompts you have to write have had to be really detailed up until this point. And I'm seeing this in my own experience, and we're seeing that as well. It's like your prompts don't have to be as good as they had to be a year ago, 2 years ago. It can understand a little bit more ambiguity. And so what that basically means is that the technical barrier to entry to writing a good prompt is like
Yeah.
really lowering. But what still is there is like, actually, if I just think of this LLM agent as just like a model that like data needs to come in, data needs to come out, and it needs to be hooked up somewhere, like actually interfacing with that, hooking them together, bringing the data in, that's like a UI problem. And you can even think of a simple like workflow sort of builder to do it. Um, and that is kind of one of the bigger areas I think for the prompts to solve. Is it's really just how do you bring it to like less technical counterparts that have the product knowledge, that have the subject matter expertise, that can write these prompts, that even really know where the data lives. They just want to like use this to deliver value. I think like in the infrastructure space, that's actually for me one of the like most interesting parts of it.
Love it. I'm looking forward to wait and see what happens. And I'm going to continue to spark more conversations to get people's different insights, how people are approaching some of these problems, and of course, what people are building. Lastly, before we wrap up, aside from curiosity, what is the one trait in an engineer that you feel they need to thrive in today's technology climate?
Yeah. I mean, curiosity is obviously very important. I think, as you already said, like it is something that the tech is evolving rapidly. You need to be able to like sort of throw off the shackles of prior experience and be willing to like try something new. I think one of the things I care the most about is like ownership. Ownership, I think, is like a very important thing. And why I actually say it's important because of technological, we can connect it to the technological environment. Really, what ownership kind of means is like, I'm not obsessed with this little feature I'm building. I am obsessed with how this is embedded into the entire experience for what I'm building.
Yeah.
And I care about what's happening upstream of me. I care about what's happening downstream of me. Now, why I say it's actually important in the technological environment is like, yeah, what LLMs are doing is it's like reducing the friction, the costs for you to understand what's happening upstream of you and downstream of you in any organization. I can ask an LLM what is going on in my infra repos. Like, where's the infra? Like, I know very little about our infra repos. I can ask an LLM. So I actually can start to see my node in the graph of the organization a lot better. And those people that feel like the thing I'm developing is important across the end-to-end spectrum, that sense of ownership, like I care about the quality of the thing, I care about the impact I'm driving, I care about how it's connected, like that is a very important skill. Because I'm telling you, you can take an LLM, you can learn a lot about your company's code base, you can learn a lot about how everything is connected very, very quickly. You can become a little bit of a front-end engineer, you can become an infra engineer. But if you don't feel that like this is a thing that brings you value, or this is something that is yours that like you're building, then you might not do it. And so I think, having a sense of ownership, having that kind of mentality to the things you build, is like, I think, a pretty important trait.
Love it. I love the upstream and downstream notion as well.
Yeah, for sure.
I want to say a massive thanks. Like, your energy is infectious. I think you've been incredible. Thanks for sharing more light on what you guys and girls at Ramp are building and how you've built things. So, for coming to spend 50 minutes with us, I do really appreciate it, Ryan. Thank you.
Yeah, no, this was awesome. I really enjoyed the conversation. I thought we got to go into some like really meaty and important areas.
No, we really did. We really did. And for everyone listening, there's the Ramp Careers site that you should go and check out, because they're doing a whole load of stuff in New York right now. So if you want to join Ryan, join other folks in the team, you've got to check that out. And of course, all the likes, shares, subscribership, all that good stuff keeps that little ecosystem buzzing around. So please do that so we can carry on building podcasts like this. And again, Ryan, thank you. You're a legend.
Thank you so much. I really appreciate the time.
Pleasure. Thanks a lot, and bye for now. Guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no_. We've also got a website which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.